All right, so let's go ahead and let's take a look at our cube here. And this cube works, well, it's a cube, and it's not really too complicated. Let's go ahead and let's make some abstract art. Now, in this case here, I've seen a few games use this aesthetic, and it's really smart choice. And when I was developing a lot of games back in the late 2000s, at least, doing prototypes of levels and whatnot, I found of this aesthetic too. First of all, what does aesthetic mean? Well, aesthetic is the general look of your game. So if you have, let's say, a game set in feudal Japan, that's going to have a different aesthetic than if you have like a space epic. It's also going to look different if you, let's say, have something, for example, that's cartoony in space versus something that's really serious in space. So the aesthetic is the general feel and the look of your level or model or scene or something along those lines, whatever it means graphically. Now, one of the things that I like to do is use the minimalist aesthetic, and this works on so many levels. If you want to be one of those people who makes games in their bedroom, garage, or basement, I highly recommend that you adopt this too. Minimalism is where you get the most amount of value for the least amount of geometry, at least amount of detail. And the idea is that there's beauty in simplicity. Now, there's a few architects who use this minimalist aesthetic. One of my favorites is Tato Ando. And if you don't know who Tato Ando is, I would just Wikipedia him. He has a lot of really good structures. Google him and you'll see what I mean when it comes to simple and the beauty of simplicity. So in this case here, we now have this cube, and we're going to make something that's block-like. And the reason why block-like works is because one, it creates something that looks cool, and two, it's easy. Okay, so what we're going to do is we're going to subdivide it, yeah, probably this amount of times. This is probably too much, so I'll count it. We got subdivide once, twice. So now we have this cube full of other faces. And by the way, when you render this, or if you were to pull this cube into Unity or Unreal Engine or any other game engine, you just see a cube. You don't actually see these faces here. But what we are going to do is we are going to go and make a abstract object, and this object could be something cool in your game. It could be like long lost ancient technology or a fusion reactor or a really cool building. Doesn't matter what it is, you can find some creative uses for it, but for now, let's go ahead and let's push E to extrude, and that's all we're going to do. We're going to take each one of these squares here, and we're just going to select it and push E to extrude. E to extrude. And the thing that you need to understand here is that not a single square can be the default. Now, you might think, well, surely you can leave one square the default. I'm going to explain why that is not such a good idea. Okay? And you can see here that this will allow us, and by the way, you actually need to push E to extrude or else this won't work. So whenever you push E to extrude, you don't use the default. The default is boring. And this is something you need to understand with computers. Something that's standard is boring. So you need to make it not standard. And by leaving one of these, you can maybe get away with one. But if you leave too many of these blocks to be the standard height, then it doesn't look very good. Okay? And you can just simply raise these up just like that here. Now, one other thing that this process does here is if you're not used to Blender, this is working on something called muscle memory. And this is something that's not talked about at all, ever, in any kind of computer science class. One of the ways that computer science works is that you have problems and you solve them. And to a certain extent, it's a little bit different than if you were to actually, let's say, become, an athlete or a musician or something like that. But athletes and musicians require on muscle memory to make it good here. So as you can see, I'm doing this maybe, well, we could do this if someone was really good at math. If we divided this 4 times by 6 here, we would find out exactly how many times we do it. But by doing this, you will get good at extruding because you're using that muscle memory. So one of the things, at least computer science doesn't do is, like if you're trying to solve a math problem or solve a problem, this muscle memory is not important. But if you want to get good at using technology, for example, you need to use your muscle memory. Okay, and this is something that that may make a little more sense. It's actually fairly close to a musician, specifically a piano player. So if you ever took piano lessons, this is for you, because the motions that you use with your mouse and the motions that you use with your keyboard are very similar to what you would have as a piano player. All right. Anyway, so you can see here that I'm making this look cool. Now you might think, well, this is kind of a cop-out, isn't it? You're just kind of extruding little squares here. Well, it depends. First of all, this lecture is only about 5 minutes long. So you have to keep in mind that whenever you make a model, there's a time factor. And time is just as important as money, especially if you're trying to make a game by yourself, because most developers, they forget about time. Okay? And maybe I'll just kind of move that out just a little bit more here. Okay, so here we go. We have our cool little abstract object. Okay, you can kind of move them out if you wish here, and you can leave the bottom flat. And the reason is that if you were to put this in a game and you added physics, the flat will make this kind of go to the floor here. So this kind of looks kind of neat here. It could be, you know, you can make some of these a lot bigger or a lot smaller than others. Something like that. Maybe make one of them on each side really big. Something like that, or two of them. Okay, and there we go. So now it's, you know, you can see that this could be a futuristic apartment complex. This could be a, you know, something like, again, I think an ancient power source when I look at this personally. But the point of this is that we now have learned how to extrude here, and we've done it enough times that you could, well, find that you're good at extruding. So remember, it's not just about getting from A to B and learning the skills. There's a physical component to getting good at computers. And again, it's something that's rarely, if ever, talked about in these courses here. All right, so you now have an abstract object, and one thing I highly recommend doing is saving absolutely everything and backing up whatever you save to the cloud. You want to save often, and you always want to save, because when you go back to it, you know, 2 years, 3 years down the road, you'll be like, okay, that was kind of neat. That was a good idea. And you know, chances are, if you're, you know, doing this for 3 years, you're going to be much better at it than you were today. And you look at your early models and you can say, wow, how far have I come? So that is a abstract object. You're welcome to make another one if you wish. This concludes the tutorial.